So this video is going to be about multivalent compounds. So the video previous to this was ionic compounds. That was when we took a metal and a non-metal and we made a compound. We looked at how to name them and we looked at how to come up with the formula. Multivalent compounds, however, are different. They use still a metal and a non-metal, but they're going to be the transition metals working with a non-metal. So anything in here from column 3 to column 12 is going to be your transition metals. So we're going to use any of that mixed with a non-metal. So multivalent compounds are going to be our transition metals. Okay, very important to know that these are our transition metals. We know that column 1, 2, 13, 14, 15, 16, 17, 18 all have nice charges that we've written on there. So the 1 plus, 2 plus, 3 plus 4 minus, 3 minus, 2 minus, 1 minus. Those are all our nice charges. I didn't write anything in here. And the reason is that we don't know what the charges are. They can be different. They can have more than one. Sometimes it might be a 2 plus and a 4 plus. Sometimes it might be a 2 plus and a 3 plus. They can be two different ones. So we don't know without looking at a table that has them all written down. So what we're going to do because of that is we're going to use Roman numerals. So we need to know what Roman numerals are. You may have seen them before in your career of school. So I is 1. II is 2, III is 3, IV is 4, and then V is 5. So how I remember this for 4 is that that's 1 before 5 is 4, and then V is just 5. VI is 1 after 5, which is 6, and then we won't really do a whole lot after 6, so we'll just leave it as 1 to 6. Okay. So what we're going to do is learn how to name them and learn how to come up with their compound, their formulas. So I guess we can do the naming first. So naming. So if I give you a compound, so we need to take a transition metal, something like cobalt, so CO. And then you take a non-metal, Cl2. Okay, so if I give you this compound, COCl2, we need to name it. I need to know what the name is. So we need to look at what CO is. CO is cobalt. We need to know what Cl is. Cl is chlorine. And again, whenever we're naming them, we're always going to change that second element, our non-metal, to IDE. So it's going to become chloride. So we're going to write down cobalt. And then chloride. So again, CO is cobalt, Cl is chlorine. We change that to IDE for chloride. However, I left this kind of nice little space here. We need to indicate what the charge on cobalt is. This is very important. So anything that's a multivalent compound is going to have those Roman numerals. Want to say hi, Joey? Joey likes to say hi. Okay, I'm busy. Okay, so we need to put a Roman numeral in there. What we're going to do to figure that out is we need to crisscross the charges backwards. So we know that Cl has a 2 here, CO has a silent 1 here. We're going to cross them back. So that's going to look like this. It's going to look like CO with a 2 and a Cl with a 1. Okay, chlorine's charge is 1. We know that. Chlorine has a charge of 1. That means that is good. Chlorine is good. It has that charge of 1. Cobalt, then, therefore, is a 2. The charge on cobalt has to be 2. So we put a 1, 2 in there for cobalt 2 chloride. And we're going to do 2 more examples so it makes more sense. If we take Fe2O3, and we try to name that, Fe is somewhere on here. Fe is iron, and then O is oxygen. So Fe is iron, leaving a space for that Roman numeral, and then oxygen becomes oxide. Again, we're going to flip back the charges. So the 3 is going to go in the Fe, the 2 is going to go in the O, so Fe3, O2. Is oxygen a charge of 2? Oxygen is a charge of 2. So therefore, iron is a charge of 3. So 1, 2, 3. Okay. One more. I want to get a little bit tricky one. Let's see here. If I do Ti Se. Okay, so we have TiSe. Ti is titanium and Se is selenium. So titanium. Leave that space for that Roman numeral. And then selenium, which we're going to change to selenide. Celenide, selenide. And again, we're going to cross back the charges. So there is little silent ones here. We're going to cross those back. So Ti1, Se1 is selenium 1. No, selenium should be 2. So that means I need to times this by 2. So I'm going to times this by 2. If I times that one by 2, I also have to times this one by 2. So it becomes Ti2, Se2. So again, selenium is 2, and that's what we want. We need selenium to be 2. So to change it to 2, we times it by 1 by 2 to get 2. And we have to do the same thing to titanium. Therefore, the charge of titanium is 2. Okay, so TiSe becomes titanium 2 selenide. This one here is a tricky one only because it looks like it should be 1, but it's not, because you have to always verify what the charge is on selenium. So we verify what the charge is on oxygen, we verify what the charge is on chlorine. We need to make sure we're always verifying that charge, because sometimes we're going to have to do this multiplication trick. Okay, the next thing we're going to do is we're going to come up with the formulas. This is a little bit easier. So if I give us the formula, zinc, 2 chloride. So we need to find out what zinc is. Zinc is Zn, and again, chloride is chlorine, and that's Cl. So we have Zn, Cl. However, we need to know the charge on Zn and Cl. So Zn is in the multivalent section. We don't know what its charge is. Chlorine has a charge of 1. So chlorine has a charge of 1. How are we going to find out what charge is on zinc? Actually, this Roman numeral tells us. So the charge on zinc is 2. That's why those Roman numerals are there. The charge on zinc is 2, and chlorine we found from the periodic table. So we're just going to drop them signs, cross them, and it's going to become ZnCl2. Just like that. If I do another one, if I do silver, 1, nitride. Silver is somewhere on here, Ag, right there. And then nitride is nitrogen right here. So again, Ag is in the transition metal, so we don't know its charge. Nitrogen is N, and it's a charge of 3. So we come over here, we go Ag, N3. However, silver tells us its charge. Its charge is 1. So we drop the signs, we cross them, it becomes Ag3, and then N with a 1 there. Okay, one more. If we do copper, 4, fluoride, copper 4 fluoride. So copper is, again, a transition metal, so we don't know its charge. Fluoride is fluorine and has a charge of 1. So copper, fluoride there with a charge of 1. Again, this Roman numeral tells us the charge, so the charge on copper is 4. We drop the signs and change them, becomes Cu with a little 1 there, and then F4, just like that. Again, with these types, you can reduce them if they reduce. However, none of these examples did reduce, but sometimes you might have to do so. Always watch out for reducing. Always watch for reducing.